A chain weighs 36 ounces per foot. How long is a piece of this chain that weighs 180 ounces? This problem involves a rate. A rate describes a relationship between two different kinds of units. The word per is often used to express a rate. I can see the word per right here in our problem. When a rate is expressed using the word per, there are always units in front of the per, that's the ounces here, and there are also units just behind the per, after the per. Those units are represented by the word foot here. The rate in this problem is 36 ounces per foot. We want to find out how long a piece of the chain is that weighs 180 ounces. We know the weight of a piece of chain. We want to figure out how long it is. How long here means how many feet of chain would have this weight of 180 ounces. So let's use the rate to help us solve this problem. The rate here is 36 ounces per foot. That means that 36 ounces is the weight of 1 foot of the chain. And in fact, right here in my pocket, I just happen to have a 1 foot long piece of the chain. There we go. Whoa, this is pretty heavy, 36 ounces, that's over 2 pounds. So here's a 1 foot long piece of the chain. Now, we need quite a bit more than this if we're going to have 180 ounces of chain. So let's try to figure this out. If we added another 36 ounces, that would be like making our chain 1 foot longer. That's like adding 1 more foot to the chain. 36 plus 36 is 72 ounces. 72 ounces is the weight of 2 feet of chain. Now that's more. Let's just keep adding on 36 ounces till we get to that 180 ounces that we're trying to reach. So I'll add on another 36 ounces. That means I'm adding on another foot to the chain. 72 plus 36 is 108 ounces, which is the weight of 2 plus 1 more foot, that's 3 feet of chain. Now we're getting there, but we still need more weight, more ounces. Add on another 36 ounces. That will increase the length of our chain by another foot. Let's see what we get. 6, 4, 1, that's 144 ounces is the weight of 4 feet of chain. Now we have quite a few ounces here. Let's add another 36. That means we're going to add on still another foot to the length of chain that we have. 144 plus 36, I get 0, 8, 1. There's 180 ounces. 180 ounces is the weight of 5 feet of chain. So we've actually solved our problem. We wanted to know how long a chain that weighed 180 ounces was. We now know the chain would be 5 feet long. So 5 feet of chain weighs 180 ounces. Now we've solved our problem, but I have to admit that was a fairly complicated way of working through to the answer, adding 36 to it up over and over again. There's an easier way we could have approached this. See, what we were trying to do was figure out how many times 36 actually goes into 180. How many times 36 ounces goes into 180 ounces? Because we're trying to figure out how many times 36 goes into 180, we could have just divided to solve this problem. 36 into 180. Let's go ahead and solve the problem that way, by dividing. So for the shorter way to solve this problem, we just take the total number of ounces, the 180 ounces, and we want to see how many times 36 ounces goes into 180. Each time 36 goes in, that stands for 1 foot of chain. How many times does 36 go into 180? Well, I think we just saw that 36 times 5 is exactly 180. So 36 goes into 180 5 times. 5 times 36 is 180. Subtract, and we've done the division. 5 feet of chain would weigh exactly 180 ounces. So 5 feet of chain weigh 180 ounces. And I just happen to have, 5 feet of chain right here. Let's take a few more minutes to look at this rate problem a different way, a third way. This other method involves looking at how the units are related to each other. The units in this problem are ounces, feet, and ounces per foot. This new method is especially helpful when we are working with more complicated numbers like fractions and decimals. We're going to work with the units by setting up a unit equation. Let's look at the unit equation for this problem. The unit equation involves the words attached to the units, not the numbers, just the words. We're going to write down an equation in words. We start out with the words involved in the units for the rate. That's ounces per foot here. All right, ounces per foot. I can take the rate and multiply by a quantity whose units are represented by the word after the per. That's the word foot here. Now we write foot in the rate because ounces per foot stands for how many ounces correspond to 1 foot of the chain. But I multiply by the word feet because I could have any number of feet in this position. The units after the per match up with the units that I multiply by. The result that I get after I multiply will have units that are given by the word in front of the per. That's ounces here. Ounces per foot times feet equals ounces. Let's think about this a little bit more. If I take a rate, like ounces per foot, and multiply by units given by the word after the per, that's feet, I end up with a result whose units are given by the word in front of the per, that's ounces. Again, ounces per foot times feet equals ounces. Now let's go ahead and fill in some values for these quantities. In our problem, we know that the chain weighs 36 ounces per foot. So the rate is 36 times the number of feet we don't know. We're trying to determine how many feet of the chain have a certain weight. So I write a box with a question mark. That's what we're trying to figure out. Equals how many ounces? Well, 180 ounces is the total weight of the longer piece of chain. That's a piece of chain I just pulled out of my shirt. So when we fill in the numbers below the unit equation, we have 36 times box equals 180. While this is a multiplication statement, we're missing one of the multipliers here. We're missing the number of feet. So we can divide to find the number of feet. We take the answer to the multiplication problem, that's the 180, and divide by the multiplier we have, 36, to get the missing number. Here, because whole numbers are involved, we can do long division. 180 divided by 36. And we've already figured this out, so I won't go through the steps again. We found out that 36 went into 180 5 times. 5 times 36 was 180. Our division came out even here. 5 feet, that was the length of the piece of chain that weighs 180 ounces.